Yes.
Good. So we go back to, no, actually this was just factoring. So we left off at 14. So did you have any difficulties with 1 through 13 in WebAssign? Okay, perfect. So we're moving on to P of x, which is negative 3, x plus 4, 3x minus 2, everything squared. Find the y-intercept of this graph. How do I find the y-intercept? Yes, I have to find P of 0. This is the y-intercept. So P of 0 will be, how much is 0 plus 4? Very good. How much is 0 minus 2? And negative 2 squared. I think we just determined that, though. Okay, so this is times 4 and is a negative 48. We determined that. Okay. And behavior. And behavior. So, in other words, the question is really asking us what happens here and here. In other words, when x approaches negative infinity or infinity, where does the function go? And here's how we think about it. So can anyone tell us the degree of this function? The degree is? So 3x squared will be squared, but then I have to multiply by x, right? So degree is 3. A degree that is a function that is degree, a polynomial function degree 3 has the following two options. Like the linear function. If the linear function has a positive slope, it looks like this. If the linear function has a negative slope, it looks like this. The same thing for any odd degree. So this is a degree that is 3, like the first degree. It either looks like this, coming from negative going positive, or coming from positive going negative. One or the other. There is not a third option. Now I have to identify the leading coefficient. Because if the leading coefficient is positive, negative infinity to positive infinity. If the leading coefficient is negative, positive infinity to negative infinity. Can anyone identify the leading coefficient for us? Leading coefficient equals negative 3. So then, is it this or this? This one. So from positive infinity to negative infinity. So positive infinity, negative infinity. That's the end behavior of the function. It's based on the degree and the leading coefficient. Okay, determine the zeros of P and their multiplicities. What did we say the zeros represent? Very good. X-intercepts or zeros of a function. They mean the same thing. Perfect. So I have this function, P of x, and I have to set it equal to 0. So how many solutions will I get? How many x-intercepts will I get? How many zeros will we get? Actually 3. The degree is 3. If the degree is 3, I have to find 3 solutions. Mandatory. However, you are correct in a way because 2 of them will repeat. But still I have degree 3, I have to write 3 solutions. So one of them is x equals perfect, and the other one is x equals 2/3 indeed. And this is what we mean by multiplicity. What is the multiplicity of x equals negative 4? How many times does x equals negative 4 appear? And the answer is once. What is the multiplicity of 2/3? In other words, how many times does 2/3 appear? 2. Remember, the sum of the multiplicities has to equal the degree. The sum of the multiplicities must equal the degree. Okay, what are these multiplicities so important? So what? Okay, one solution, negative 4, and 2 solutions, 2/3. So what? What does that mean? Why is it so important? So here's the reason. When a function has a solution that has a zero, if you want, or x-intercept has a zero, or x-intercept that has a multiplicity 1, like the one for -4. I'm not going to show it at -4. It doesn't matter. It looks like this. It's a straight cross. It could be from below to above or from above to below. But this is multiplicity 1. M equals 1, M equals 1. Well, multiplicity 2 is a term. This is M equals 2. At any point, anywhere on the x-axis, where the function has two solutions that are identical, like in this case, 2/3, the function must turn. Either from above going back above or from below going back below the x-axis. So the multiplicity that is even, the function will always turn. A multiplicity that is odd, the function will always cross. What about m equals 3? Do we have a function like that? Sure, we do. X cubed equals 0. That's why the graph of x cubed is not this. The graph of x cubed is this. It's a turn, but a very slow turn, because the multiplicity is 3 of x equals 0. 3 solutions, x equals 0. So that's the connection between, or the importance of multiplicities. They tell us whether a function turns or crosses, and how it turns and how it crosses the x-axis. So one more time, an odd multiplicity crosses. An even multiplicity turns. But it depends how also. Any questions? Since we determine, I don't want you to graph this by hand at this stage, because in chapter 4, this is what we're going to do. We're going to graph these functions, all of them, by hand. So, but since we discover that it crosses, so I'm going to write here cross and turn. And since we know the end behavior, it's coming from positive and going to negative. So I know that the graph of this function, so this is -4, and this is 2/3. So it's coming from above, and it crosses at -4. So it has to turn at this point. So I know that this is the graph. But I don't want you to graph it with details, because other than that, because there is no point. I mean, you can find the x-intercept, which we did. What was it? Oh, so it was much lower. So it's like this then. Yes, we did find it. What was it? -48. So yeah, I will have to redo the graph. I forgot about that. So I'm going to say that this is -48. So it does this then. And it turns here. So yeah, you can select from here, but yeah, they had to use such a scale. So this is a potential. I have to look at the other ones. Yeah, this is the only one. Okay. Moving forward. So we have 12x. This is number 15. So we have f of x equals 12x over x squared plus 7. What do they want? Is the function odd, even, or none of the above? This is also something that we are going to use throughout the semester. So that's why it was chosen here. So for odd functions, f of -x equals the opposite of f of x. For even functions, f of -x is identical with f of x. If you need more explanation on this, please stop me and I'll explain. If you remember this, we move on. If you don't, I'll explain. Do you remember this? Don't be shy. Okay, so a function that is odd is like x cubed. Whatever we have in this quadrant, it's a copy of this quadrant over the origin. So that's why here f of negative x will be negative f of x. And that's an odd function, so these are functions. Now for an even function, the simplest example is x squared. X squared, I can fold the paper with respect to the y-axis, and you see it will overlap. So it means that f of negative x equals f of x. So if I replace everywhere x by negative x, nothing will change. I'll still have the same function. Why is it important to know that a function, whether a function is odd or even? It will be easier to graph. So it's always good to know whether a function is even or odd, or none of the above. Okay, so now all we have to do, obviously, we have to determine f of negative x. So I'm going to replace x by negative x everywhere and see what happens. So let's do that. So f of negative x equals 12 times negative x over negative x squared plus 7. But negative x squared is the same with x squared, correct? And 12 times negative x is the same with negative 12x, correct? So this can be rewritten as negative 12x over x squared plus 7. Agreed? So here I'm asking myself three questions. Does this equal f of x? If you say yes, then I'll say the function is even. Does this equal, what is the second option? Negative, very good, f of x. If it's yes, then it's odd. Or none of the above. A function cannot be odd if it's a function. Cannot be odd and even at the same time. There is one, but nobody cares about it. This y equals 0. This is symmetric with respect to the origin and symmetric with respect to the y-axis. But who cares about this function? But non-functions can be symmetric with everything, with respect to everything, the origin and the x-axis, y-axis. But not functions. Okay, so I have to compare this to the original function. Are they the same? Are they the same? No, so then the function is not even. Now I have to compare this to the opposite of the function. I'm sorry, I have to compare this to the opposite of the function. If I put minus minus, do I get the same thing? If I put minus and minus, do I get the same thing with this? Yes. Yeah, of course. So a function is indeed odd, symmetric with respect to the origin. So they say here it is odd because f of negative x equals negative f of x. Okay, a few more. 6 more. And then we can start chapter 2. Although I would like to look at a couple of difference quotients for different functions. Okay, any questions for me? Okay, the next one is log base 6 of x minus 2 plus log base 6 of x plus 3 equals 1. They're asking us to solve for x. First of all, what type of equation is this? Say it again. I just didn't hear. Of course, it's a log equation, of course. Okay, what is the restriction for this to exist? When will this log exist? For which values of x? Right, x minus 2 greater than 0. Good. What about this one? What is the restriction for this? Very good, awesome. So then when we solve this inequality, we get greater than 2. When we solve this inequality, we get greater than -3. So what is the domain of this function? Greater than 2, greater than -3. Both have to be fulfilled at the same time. Say it again. Indeed, that's where they overlap, right? So if you graph between -3 and infinity, we get this. If you graph the other one between 2 and infinity, you get this. And you want both colors at the same time. So then the domain is 2 to infinity. What does this mean? It means that if the solution is not a number greater than 2, the equation has no solutions. Good. So how do we condense this part? The left-hand side, how do we condense it? It's a sum of two logs with the same base.
You just do x minus 2 equals 1 and x, no?
No. How do we condense sum of logs? It's log base 6 of the product. Log base 6 of x minus 2 times x plus 3. What is the next step? So first we have the next step would be to change it into an exponential equation. The base raised to the first power equals this. Base raised to the first power equals x minus 2, x plus 3. Let's solve this equation now. What type of equation is it? Very good. So we have to do what? We have to set it equal to 0. Yes, distribute and set it equal to 0. Very good. So let's do that. Let's distribute and set it equal to 0. So we have x squared plus 3x minus 2x, which is plus x, and then minus 6, and then minus 6 equals 0. Or x squared plus x minus 12 equals 0, and I'm waiting for you to factor it. How do we factor that?
X plus 4 and x minus 3.
Very good. So then we have two potential solutions. What is the first one?
X minus 4.
Very good. And
3.
And I will say not so fast, because I have to go back here. So what do I conclude?
X is equal to 3.
That's why we state the restrictions or find the domain of the function before we condense it. Before we condense it. Do not find the domain after you condense it, because it will be different. Or it could be different. Any questions on how to solve the log equation? Any questions? Okay. Find the exact value. Okay, for that, I just want to refresh your memory on this. Okay, sine pi over 6. Say it again. 1/2. And cosine pi over 3 is also 1/2. sine of pi over 3.
Square root.
And this is also the square root of 3 over 2. And these two are the same, which means excellent. Good. So please remember this. You don't need to memorize anything else. Now the next question, which is 17, it's asking us to find tangent pi over 4. No one cares about tangent pi over 4. We do, right? But what I meant to say is that it's this over this, so obviously it has to be 1. And you cannot forget this is the easiest, right? Because both sine and cosine are the same. Okay, next one is sine number 18. Any questions for me, please? Any questions here? Is this okay? Yes? Okay. So sine 7 pi over 6. And here's what I recommend with that. If you know a different method and you're happy with it, I am happy with it. First of all, when you throw at me 7 pi over 6, I have to think for a moment because I know pi over 6 is how many degrees? 30 times 7, which is 210, right? So I will present it in the unit circle. I will definitely present it here. This is the 7 pi over 6. 210 degrees, right? So this is, how much is this then? This piece, just this piece. Of course, pi over 6, right? It's the 30 degrees. Good. So now I look at sine and I know that sine is positive above the x-axis and is negative below the x-axis because it's measured on the y-axis. So sine is positive and positive, cosine is positive and negative. So obviously I will expect a negative number because in the third quadrant sine is negative. So now I will write simply sine pi over 6, knowing that sine pi over 6 is 1/2 with minus in front. This is negative 1/2. Any questions? Any questions? Any questions? Okay. Oh, they got negative 1/2 as well. Okay, so secant 5 pi over 3. Pi over 3. Again, I have no idea what this means, but I know that pi over 3 is 60 degrees, and 5 times 60 is 300. So if this is 360 degrees, 300 is 60 degrees shy of it. So this must be the 5 pi over 3. I also never care about secant because I know is 1 over cosine. So I know that the reference angle is 60 degrees, or pi over 3. I also know that cosine is positive on this side, so the answer will be positive. I don't have to put that, but I'm just emphasizing. So this is obviously cosine pi over 3. I go back to cosine pi over 3. I know it's 1/2. So the answer will be 1 over 1/2, which is 2. Now, the next, any questions, please? Any questions? Now, the next one is a trig equation. So sine 2x equals sine x. It says find all values of x such that such and such, but they restrict everything to 0 to 2 pi. Okay, so just one complete circle. So what do we do next? Well, we have to remember an identity here. We can't work with this without remembering what sine twice x is. Do we remember the identity sine twice x? That's 2 sine x cosine x. I will subtract sine x and set it equal to 0. What next? I will have to look at these two terms and say you must,
Simplify.
I cannot divide by sine or cosine. Yes, I'm factoring out sine, so this is 2 cosine x minus 1. So there are two options. When sine x is 0 or when cosine x is, move -1, it becomes positive, and you divide by 2. This is good, but we didn't finish. We didn't solve for x. We only solved for sine x and cosine x. So sine x can be 0, and cosine x can be 1/2. Any questions so far? Okay, so then sine x is 0. Remember, sine is measured on the y-axis. So these are the two options in which sine is 0. So x equals 0 and x equals pi. Now we also need to solve cosine x equals 1/2. And cosine is positive here and here. So we will find an angle in the first quadrant and an angle in the fourth quadrant. We already found the angle in the fourth quadrant. Oh, it wasn't for cosine. Sorry. Yeah, it was for cosine. 5 pi over 3. Cosine pi over 3, 1/2. So they're asking us for solutions between 0 and 2 pi. What I would normally do, I would not present them like this, but that's fine. So one angle is 5 pi over 3. We just determined that. And the other one will be pi over 3. And since they closed, I'm sorry, they normally don't include the 2 pi. So it's 0 or 2 pi is the same thing. But I have to write it also as 2 pi. So x equals 2 pi as well. Because they normally don't include. You don't have to repeat it. But 0 or 2 pi is the same angle. I didn't want you to enter it without 2 pi and give you an error. Okay, I think 21 is 21 and 22. Last two. So we're asked to graph y equals 3 sine 2x without using a calculator. Fine. First of all, what is the period of sine in simple plain sine? So the period for sine is 2 pi. The period is everything for all trig functions is 2 pi except for tangent and cotangent, which is pi. So everything has 2 pi except tangent and cotangent. But this particular one, the period for this function is 2 pi divided by this number, which is pi. It's a horizontal shrinking of the graph. You'll see how I can also graph it with the graphic calculator just to show you what I mean. But let's do it anyway. So first of all, the graph of sine, looks like this. At pi over 2 is 1, at 3 pi over 2 is negative 1. That's sine x. But this one, first of all, has a 3 in front. So the height for sine is 1 and the minimum is negative 1. But because of this 3 in front, it will go to 3. So 1, 2, 3. 1, 2, 3. And furthermore, it will have a period of pi. So this will be the graph. Yes, I can continue forever, but this is the complete rotation, if you want, a complete graph from negative 3 to 3, and this is 3 sine 2x. I don't care how many periods they want in here. It's very confusing in a way. I just think it's kind of difficult to read. But anyway, so let's also do this with a graphing calculator just to check. Ready? What happened to my... Oh, yeah, I had to turn it off because it went berserk on me. Okay. So in y equals, make sure you have the mode in radians, though, right? So we want to graph sine x, and we want to graph 3 sine 2x. And, of course, I'm going to change the viewing window. I don't care for all this. I just want to see between 0 and 2 pi. And, of course, we're going to see two periods for the second one, right? Because it's double. So from 0 to 2 pi with a scale of pi over 4. And I only want from negative 4 to 4 because I know it's not going to go further than that with a scale of 1. And now graph. I'm checking my mode. Yes, radians. And now graph. So here's sine crossing at pi, going to 2 pi, negative 1, 2 pi. And this is 3 sine and another one because I chose to present everything between 0 to 2 pi. So this is the sine, 3 sine 2x, and this is sine x. Any questions? So in my graph, to have the exact same thing, they also presented one more period because I chose 0 to 2 pi. If you have chosen this, it would have been just one complete graph. Any questions? Any questions? This is a lot. Okay, last one, arc sine 5 pi over 6. Arc sine of sine 5 pi over 6. Now you have to be very careful with this kind of problem because when you apply the inverse function to a function, you will be tempted to write 5 pi over 6. But there is a catch here, right? And when I apply to a function, when I apply its inverse, these should cancel out and I should just copy 5 pi over 6. However, in this case, it's not that. Why? Because we had to restrict the domain of sine to negative pi over 2, pi over 2. Otherwise, the function is not one-to-one. Look at this graph. So the blue graph is not one-to-one. By the horizontal line test, it's not one-to-one. But if we restrict the domain to negative pi over 2 to pi over 2, like this now becomes a one-to-one function. So in this case, I cannot use the property of inverse functions. I have to determine what sine 5 pi over 6 is, and then apply arcsine to it. So arcsine of sine 5 pi over 6, this is 1/2. 5 times 30 is 150. It's in the second quadrant. This is 1/2. And this is arcsine 1/2 is pi over 6. So careful, I don't know if you remember this from pre-calc. You can only apply the property of inverse functions only when certain conditions are fulfilled. Like here, the answer must be between negative pi over 2 and pi over 2. The answer to arc sine, it cannot be 5 pi over 6. It must be between negative pi over 2 and pi over 2. Okay, so now you have all the information to complete this assessment, the skills assessment. If you come across problems that are similar and you need help with them, so please let me know. We can stay after class or whatever, I can help you with anything. So this assignment should be done between now and Wednesday, correct? Okay, so my next step is I'd like to, we did look at a square root function, but I also would like to look at, yeah, Pam left me a message. She stopped by and she put, enjoy the new semester. She just retired and she's smiling and very happy. So, yeah. So, I just saw this note. I didn't know what was in there. What is this? Oh, okay. So now I know. Okay, so I would like to before we start chapter 2, I would like to just go over at least one more or two more functions with and determine the difference quotient. If you have any preference, let me know. We did a radical function. We can look at a quadratic. We can look at a rational. Any function that you would like to look at. We're going to do this over and over. It's not going to end here. But let's just look at one more and find the difference quotient and simplify it. Rational? Rational. Can anyone give me a rational function that you want to work with? Anyone? Okay, 2x plus 1 over x minus 3. Is this a rational function? Is it a rational? Yes? It's a ratio of two polynomials. Is it a rational function? Of course. So then x does not equal 3, of course. So we want to find the difference quotient and simplify it. Does anyone remember the definition of the difference quotient? We have to remember it in this class. F of x plus h minus, excellent, divided by, excellent, great, good. I'm going to copy f of x and h, and I want you to give me f of x plus h. Say it again. Okay, so 2x plus 2h plus 1 over. Do we understand what we're doing? Because maybe that's not clear. Yes? I don't think that this is clear, is it? No. Okay. So let's look at, I'm going to come back. I'm on 6, 7, 8. Okay. So let's say I have this function. And I want to find f of x plus h. What does the function say to me? It says this. Correct? So if this is x plus h, then this is x plus h, and this is x plus h, correct? That's the pattern. Whatever squared plus 2 times whatever plus 5, correct? Now, our function is a rational function, which is 2x plus 1 over x minus 3, which is basically the same thing. It says, if this is x plus h, then this is x plus h, and this is x plus h. That's all I have to do, correct? Are you with me? So then 2x plus h times 2 is this, and then plus 1, and then over x plus h and minus 3, correct? So that's how we evaluate a function for anything, right? For a number, for another variable, or whatever we need to plug in. Good. So our next step would be to do what? To find the least common denominator, which is, we are subtracting two fractions and we need the least common denominator. Very good. X minus 3, x plus h minus 3. Awesome. So we have to multiply the numerators now by appropriate quantities. So x plus h minus 3 was multiplied by x minus 3 to get this. What do we have to multiply the numerator by? Excellent. X minus 3 was multiplied by x plus h minus 3 in order to get this. We also have to multiply its numerator by x plus h minus 3. Very good. Now we have to take care of the numerator. Be very careful because we have to distribute x to 3 terms, -3 to 3 terms, 2x to 3 terms, 1 to 3 terms, and everything gets an opposite sign on this side after this, right? Good. So x times 2x, x times 2h. Excellent. X times 1. I need the sign as well. -3 times 2x. Perfect. -3 times 2h. -3 times 1. Very good. 2x times x with minus in front. 2x times h with minus in front. 2x times -3 with minus in front. 1 times x with minus in front. 1 times h with minus 1 in front. And 1 times -3. Yes, with minus in front. As you notice, I ran out of room. I always do. It's never a surprise. Okay, so now my question is, what has to happen? There are two things that must happen here. Every time we determine and simplify the difference quotient, two things are expected to happen for sure. The first one is all terms that do not have h must go away. Maybe some terms with h go away, but that's fine. That's a bonus. But all terms without h must go away. So let's take a look. 2x squared goes away. 2xh goes away. X goes away. 6x with positive 6x. Positive 3 with -3. What is left at the end? So I'm looking everywhere. I see a -6h. I look everywhere and I see a -h. So then the numerator is? Perfect. Divided by x minus 3, x plus h minus 3. And I flip this. This was h over 1 times 1 over h. So indeed, all terms without h went away, and even some extras. And now what is the second thing that has to happen? This h must go away, the one from the denominator, somehow simplified, and this is the final form. As you've noticed, there is still an h in there, but it doesn't bother anyone. Please get used to this because it will follow us everywhere, this course. Any questions on this? Any questions?